Hello everyone, it's Asatte Games. Today I will show you how you can implement a shooting mechanic to your default game. For this tutorial I have used the project from the HP bar tutorial. You can go and download it from my itch.io page. At the end of this tutorial I will also upload this shooting enemy project to my itch.io. You can download this project too. I will leave the link to the comment section. For this we will need some assets. There was a bunch of assets from the previous tutorial. I have also added an arrow and enemy sprites, so we will be using them. And this is how the game will look at the end. We will have our player, monsters will follow us, we will shoot the closest monster, and if we hit the monster, we lose health. And the monsters also have their health, so when they hit twice, they will die. Now to be able to use this image, we will need an atlas. I already had an atlas from the previous tutorial. Image atlas. If you don't have an atlas, right click new atlas and name it image atlas. On the atlas, let's say you don't have the image, right click, add image, select the image you want to use, and that's it. On the main collection, we have our player. Player has two collision shapes. One is player collision, this small circle. This is where the player interacts with object. When player hits a spike, player loses health, and same with the monsters. And we have also a range collision shape. This is the area where player can detect monsters. So when a monster enters this area, we will save it in a table and use it to calculate the closest monster we can shoot, then shoot at it. To add a new collision shape, right click to the game object, add component, select the collision object, name it range collision. On the collision, right click, add shape and select sphere. On the sphere, you can set the diameter. On the collision object, set the type to trigger because we don't want this to stop monsters from coming in. We want this to detect it, and trigger is used when we want to detect collisions. Its group will be player range and it will see the enemy group. I have already explained other components on the previous tutorial, so if you also want to learn about them, you can go and watch that tutorial. But we basically have an HP bar sprite, and the outer part of it, we have a sprite for the player. We have a script that controls the player, which I will show you in a second. And I have also added a factory. If we want to be able to shoot arrows, we will need to instantiate them, create them. So for this, we will need a factory. Right click on the player, add component, select factory. Factories accept a game object prototype. For this, we will need to create an arrow game object. So for this, on the resources folder, right click, add new game object, name it arrow. On the game object, right click, add component, select sprite. On the sprite, we will select the image atlas and select the correct animation. We will also need a collision object so arrow can interact with enemies. So right click, add component, select collision object. On the collision object, right click, add shape, select box, set the dimensions of it. On the collision object, set the type to trigger and set the group to bullet. It will also see the enemy, so put enemy in the mask. We will also need a script to control it, so on the scripts folder, right click, new script, name it bullet or arrow. This is a simple script. First, we create 4 property to the game object. You can use gameObject.property and set the name and apply some properties to the game object. It will have a speed variable with 3 as the value. It will have an attack variable with the value of 60. It will have a life timer which will start from the 0. We will increase this, and when it reaches a certain value, we will delete the object. So when it missed an enemy, it will not forever go towards one direction. It is a good practice to put a timer on bullets. We also have a direction property. It is a vector with the value of 0. It has two functions. The first one is update. On the update, we first increase the life timer by delta, and if it is greater than 5, we delete it. So each arrow will be deleted after 5 seconds. If we still have time, we check if our direction's length is greater than 0. That means arrow is set with a proper direction, so it can move. To make it move, we use our generic approach. We get the position and we increase the position by this amount. We normalize the direction, because if you don't add this, when the direction has a value like 1 to 0 or 0 to 1, it will have a 1 speed, but if it is 1 and 1, its speed will be around 1.4. So to avoid this, we normalize it, multiply it by speed and delta. Speed is how fast it is going to be. Delta ensures arrows will have the same speed for different devices. So if you have a slow computer, it will not move slower. But if you don't add the delta, that is what it's going to be. Lastly, we set the position. This part makes the arrow move, and this part deletes it if it has reached its end of life. We also have an onMessage function. On the message, we check if the trigger response message is received. This message is triggered when our collision object collides with another collision object on the mask. So when we collide with an enemy, it will send a trigger response message, and we use message.enter because before this game object is deleted, this function may be called a few times, and maybe this message will be sent a few times. Message.enter ensures this part will only be called once, and this is when they first collide with each other. We check if the message group is enemy. That means we have collided with an enemy. Then we send a message to the other ID, which is the enemy, because we have collided with it. We send a change HP message to the enemy, and as the value, we send our attack value, but as negative value because we want to decrease the HP of the enemy. Then we delete the arrow. So when we spawn an arrow and set the direction, it will move towards some direction. If it hits an enemy, this part will be triggered and it will send a message to the enemy to decrease its health and delete itself. If it doesn't hit any enemy and keeps going after 5 seconds, it will be freed. On the player's factory, select the correct game object you want to use. So when you send a create message to this factory, it will create a new arrow game object. To be able to test this, we also need some monsters. So I have added some enemies. Let's first delete them. This is our simple enemy. Enemy is a game object. It has a collision object. Under it, I have set the shape as sphere. Set the type to trigger because it will also need to trigger both the bullet and this player's range area. It will also trigger player's collision when it reaches to him, so player will lose health. Enemy also has a sprite, so add a sprite. Select the image atlas. Correct animation. Enemy will also need a script. On the init, we create 3 variables on our self table. First is HP. Enemy will have 100 HP. It will have a 28 of attack power. Its speed will be 80. On the update, we get our position, we get player's position, and we get the direction by subtracting our position from the player's position. if you know how the vectors work, this will basically give you a vector from monster towards the player. So monster will use that direction to go towards the player. Then we do the same as we did on the arrow. We add our position, this value, this is direction, times speed, times delta. This is the generic code. We didn't normalize the direction here because it is already normalized. Then we use GameObject.setPosition to set the position of the monster. Now on the onMessage function, if we receive a trigger response message, if you remember, our collision object was set to trigger type. So when it collides with a collision object in the groups of player, player range, or bullet, it will get a trigger response message. We check if the message group is player and we just hit the player. That means we have hit the player in this small circle because this one is the player collision and it is in the group of player. Since we have reached the player, then we first send a message to the other ID, which is player in this case because we have collided with the player, and tell it to change HP and set the value as negative self-attack power. So this will decrease the player's health. And then we delete ourselves. If the message is not trigger response, but it is change HP, this is the message we received from the arrow. Then we use our change HP function and use the message's value as the value. Change HP is simple. We add the value to our HP. If this is a negative value, it will decrease the HP. If this is positive, it will increase. Then we check if our HP is less than or equal to 0. That means we need to go, so we delete the game object. And this is a simple script that makes the enemy follows the player. If you need a smarter enemy, then you can watch the A-star pathfinding tutorial on this channel and make the enemy follow with a pathfinding algorithm. For this example, this much will be enough. With this, our enemy will be done. So we can copy and paste it. If you press W, you can use these arrows to move game objects, move them around. The last change we need to make is on the player script. This is a generic script where player can move around, and player also has health and also has 2 health bars. One is a GUI element and the other is in-game health bar. I have explained them on the health bar tutorial, so I will ignore them for now. For this tutorial, I have created 3 variables. One is enemies in range. This one will hold the enemies we can shoot. They are close enough, so if there is an enemy at the end of the map, you won't be able to shoot it. We will have an arrow counter and arrow interval. We will be shooting arrows every 1.5 seconds, so we will use this counter to see if we have reached this value. On the update, I have added only this part. This is from the previous tutorial. We increase the arrow counter by delta, and after increasing, we check if it has reached arrow interval, which is 1.5. So if our counter has counted 1.5 seconds, then we set the counter to 0 and call the shoot arrow function. On the shoot arrow function, we create a local variable named closest and use get closest enemy function to get the closest monster. I will explain it in a second. If this function does not return anything or the returned object doesn't exist, that means we don't have a monster to shoot at, so we don't shoot at all. But if there is a monster and it exists, then we can continue with this part. We get our position, we get closest monster's position by using get position on the closest, and we calculate the direction again, subtracting our position from the goal position. If the length of the direction is 0, that means we don't have a proper direction, So we return. If we also pass this check, then we normalize the arrow direction. Then use this tool line to calculate the correct rotation arrow should have to be pointed towards the monster. Then use factory.create and create the arrow. For this, we will use the arrow factory because our factory is named arrow, as you can see. For its position, you can just use player position, or you can add the direction value multiplied with some variable to create the arrow a bit far from the player center, so it will not be created inside of the player but around it. Then as the third variable, we send the rotation. Lastly, we can use this dictionary to set the properties. Since we had a GameObject property on the arrow named direction, we can just send the arrow direction and Defold will handle setting it. So we count till 1.5. So if there is any monster around, we shoot an arrow. For this, we use getClosestEnemy function. This is a helper function and returns the closest enemy. On the function, we first get our position. We create a local variable named closest and set it as nil. And for the minimum distance, we set it to a huge variable. So this will always be greater than value you compare. If you set a small variable here, the closest monster will never be updated. So that's why we need a very large variable. We have our enemies in range table. On the table, we use for to iterate through the enemies in range. This pairs will return the table value and what it corresponds to. The first variable returned will be ID and we will be using it. This underscore means we won't be needing the second variable it returns. We check if the ID exists because we don't want to shoot an enemy we have deleted. Then here we get the enemy's position using getPosition on the enemy ID. We calculate the distance from enemy's position to our position. If you subtract the vectors and take the length of it, it will give the distance. Then we check if the newly calculated distance is less than the minimum distance. If you are less than the minimum, that means you are the minimum. So we set it as the new minimum value, and for the closest, we set the enemy's ID. We iterate through this table. After we check for all of the monsters, we return the closest one and use it here. I think lastly we have some additions on the onMessage function. Before that, let me show you the change HP function. This part is what you would need on a generic game, and the rest of it controls the HP bars. If you don't have any HP bar, you can ignore them. If you want to use them, check out the previous video. On the onMessage function, if we receive a trigger response, that means a collision shape we have with trigger type has collided with something. If the thing we have collided is a spike, this one, we decrease our health by 15. If it is a potion, this one, we increase our health. If the thing we have collided is an enemy and it is entering the collision shape on this big circle, that means we need to register it on the enemy's range table with its ID and set the value to true. So on the table, the first variable it has is the enemy ID and the second is true. That's why with the pairs, we just ignore the second variable. But if it is an enemy, but it is exiting, that means we need to delete it from the enemies in range because it's no longer in our range. On the table, we set its value to nil. These are for the trigger responses. If we receive a change HP message, which was from the enemy script, if it reaches the player, then it sends a change HP with the value. If we receive this message, we call our change HP function and use the message value as the value on the function. And that's it. That's how you can add shooting mechanic to your default game. If you have any question, you can ask on the comment section. You can find this project file on my itch.io page. The link will be in the comment section. If you like the video and default content, like and subscribe. Thank you for watching and have a nice day.